Welcome to British University in Dubai Climate and Comfort Project presentation. This presentation is prepared by Riham Saadi, Fatima Al-Ali, and Mohammed Al-Kailani. Contents: Introduction, Site Selection, Climate Study, Design Concept, Kinetic Element, and IES Simulation. The main purpose of this project is to design a building according to lowest acceptable building code, then upgrade it to be more energy efficient through implementation of green building standards. Then add kinetic architectural element to improve the building performance. The work involves computer simulation of all scenarios and comparison of results. Site selection. Our project is located in Amman, Jordan, within the campus of Applied Science Private University. The site is located near a main highway and within an urban area that is easily accessible. The weather profile used is Queen Alia International Airport, which was the nearest available location to our site. Sunrise and sunset direction is northeast to northwest during summer and southeast to southwest in winter. Lowest and highest mean temperature is from 4 to 34 degrees centigrade. Amman is mostly sunny with 9 days monthly average cloud coverage in winter. Rain falls for 52 days and collects up to 270 mm. Windiest month is February and wind direction is mostly from west and northwest. Longest daylight is 14 hours in June and shortest is 10 hours in December. Design concept. The building was designed through understanding of all activities and the study of functionality and relationships between all internal components. The building consists of 2 floors and roof. Ground floor has reception, library, studio, gallery, computer lab, and offices. First floor has library, studio, and classrooms. Kinetic element design. The basic concept is inspired by birds' wing feathers that open and close in different positions. Based on that, we have developed a sliding fins system made from perforated metal to create shading. The system is controlled by sunlight sensors to manage kinetic element operation.
Simulation scenarios: base case, efficient case, kinetic case, and renewable energy case. The daily running mean temperature analysis was used in order to choose the suggested design days in the different scenarios. 15th of August for the summer, 15th of April was chosen for spring, and 13th of January was chosen for winter to check for the whole year season. While the times of the day were chosen according to the table of solar altitudes in order to choose times that the surfaces benefit from solar gains through the day: 8 a.m., 12 p.m., and 3 p.m. Base case materials. For external walls, U value of 0.57 was used for opaque walls and 1.15 for walls with openings as per the Jordanian building code. For external roofs, 0.76 U value was used where the allowable is 0.8. Single pane glazing was used with a U value of 5.59. Efficient case materials as recommended by the Jordan Green Building Council. That internal layer of insulation and gypsum board must be added, which lowered the U value for more than 60% to become 0.24 for walls. Green roofs were used on roofs with most solar gain, with U value of 0.17. External roof U value was lowered to 0.27 by adding insulation and gypsum board. Glazing U value was reduced to almost half by using reflective double glazing. As for the kinetic case, perforated aluminum fins were used as shading elements. Strategies are: south and west facades to be open in the morning scenario, east and west facades to be open in the noon scenario, and all elevations closed in extremely hot summer days. The efficient project orientation was detected to be with the azimuth 180 degrees, but due to restriction for the site in a university and quality views toward the valley, we decided to take the third option, which is 0 degrees. Since this building is a public building, it needs a special profile for heating and cooling, which uses full system in a period of time through the day from 6 a.m. to 8 p.m. besides being off on weekend day and public holidays. Summer scenario thermal analysis. Air temperature for room 1 was reduced by 8 to 13% through the day from base to efficient case, and 8 to 10% from the efficient to the kinetic case. Air temperature for room 2 was reduced by 9 to 12% through the day from base to efficient, and by almost 3% from the efficient to the kinetic case. Air temperature for room 3 was reduced by 12 to 18% through the day from base to efficient case, and by 11 to 17% from the efficient to the kinetic case. For solar gain, it was reduced for room 1 by over 56% through the day from base to efficient, and by over 45% from the efficient to the kinetic. For room 2, solar gain was reduced by over 62% through the day from base to efficient, and nothing from the efficient to kinetic because there is no kinetic shading there. For room 3, solar gain was reduced by over 58% through the day from base to efficient, and from 12 to 90% from the efficient to the kinetic. While for the total energy consumption, it was reduced by 32% from base to efficient, and by 5% from the efficient to the kinetic. Looking at the psychometric chart, we see that it has changed significantly and become closer to the comfort zone from the base until the kinetic case at noon. Significant solar exposure differences on the south elevation from base to kinetic cases. For the daylighting and CFD analysis, concentration was on the second floor at noon scenario for comparisons. As the base case was not accepted by the Jordan Green Building Code because it is less than 80% daylighted, we had to redesign the space, and the daylight factor was reduced by more than 48%, although it is still above the accepted zone. For illumination, lux was reduced by more than 60%. Computational fluid analysis. Temperature was reduced with more than 17%. Internal air velocity has improved slightly from base to kinetic. External wind velocity was taken at 300 degrees and speed 5.5 meters per second. As for the PMV, reduction was from 1.57 to 0.7, which is closer to the neutral. Winter scenario. Thermal analysis. Air temperature for room 1 was reduced by 1.2 to 23% from base to efficient and 5 to 14% from efficient to kinetic. Air temperature for room 2 was reduced by 4 to 12% from base to efficient and 3 to 6% from efficient to kinetic. Air temperature for room 3 was reduced by 11 to 24% through the day and by 10 to 16% from efficient to kinetic. For solar gain, it was reduced for room 1 by around 59% through the day from base to efficient and over 32% from efficient to kinetic. For room 2, solar gain was reduced by over 20% and 50% from efficient to kinetic. For room 3, solar gain was reduced by over 61% through the day from base to efficient and more than 6% from efficient to kinetic. Looking at the psychometric chart, we see that the dot has moved away from the comfort zone in this scenario, which shows that our strategy didn't work as expected in winter. Significant solar exposure differences on the south elevation from base to kinetic cases. Daylight factor has reduced by 41% from base to kinetic. For illumination, lux has reduced by more than 50%. Computational fluid analysis, temperature has decreased by 2 degrees, while internal velocity has improved slightly from base to kinetic. And external wind velocity was taken at 240 degrees and speed 4.4 meters per second. For the PMV, reduction was from negative 0.88 to negative 1.7, which is further from the neutral.
Spring scenario. Air temperature for room 1 was reduced by 22 to 4% during the day for base efficient and almost 4% to 10% reduction from efficient to kinetic case. Air temperature for room 2 was reduced by 90 to 6% during the day from base to efficient and by 4% reduction from efficient to kinetic case. Air temperature for room 3 was reduced by 26 to 11% during the day from base to efficient and by 20 to 50% reduction from efficient to kinetic case. The solar gain in room 1 was reduced by 65% from base to efficient and by around 50% reduction from efficient to kinetic. Solar gain in room 2 was reduced during the day, around 63% for base to efficient, and no readings detected in reduction from efficient to kinetic case. Looking to symmetric chart, we see that it is in comfort zone and moving out to be colder. Significant solar exposure differences on south elevation from base to kinetic cases. Illumination differences, the lux was above 3000 and was reduced to around a range of 250 to 470. Computational fluid dynamic, the temperature is reduced by 15%. Internal wind velocity is increased. External wind velocity, the wind direction 110 degree and the speed 0.9 meter per second. for PMV is reduced from 0.36 to 0.042, and that is considered a neutral range. Renewable energy solar power. The solar PV system will be on the roof right side of the building. The solar size is 370 watt with total area 1.94 meters square. So we need 82 panels to cover the selected roof area. The energy required in our building is 115 megawatt hour and the PV generates 63 megawatt hour, so the net demand is 52 megawatt hour. Life cycle analysis allows to evaluate the environmental impact of buildings. Energy consumption has the most impact on environment. The building generates 4,240 tons of CO2 equivalent per year, with 49.87 kg of CO2 equivalent per square meter, and social cost of carbon of 950,000 dirhams. A grade award to this building is grade B. This is the end of our video. Thank you for watching and have a nice day.